Yeah.
Oh yeah, where can
I
I
like
go
it.
with this one so I can make it a 3D print design?
Yeah,
Oh,
because the question is if we
Because
start
I
out with
have,
the big one, we're gonna need a test
city,
location
they
site
have a
too.
3D printer.
Oh,
So
yeah.
I'll
Oh,
be
yeah.
able to start earning, like something nice to make the 3D parts.
We
Wow.
gotta also make sure you make
with
the
that-
While
results
we are
good.
in
What is
With that, all the parts are already here. Like for example, like you can download all of the parts like right on the site.
Oh, okay.
Yeah.
Okay, so
Can we do it?
we can we? We can do it our own, right? Like,
Oh no, yeah. Like this is like the design that he has, but like the more important thing that this site has is the coding for Arduino, because like I said before, the hovercraft it's pretty open to interpretation of like what you want the design to be. As long as you have certain key features, like for example in the video, you know how you cut out those holes in the hull in order to let the air out. Like that's like the main thing you need. As long as you have like a way for the air to fill up your skirt, your design could really be anything. Like I said, it could be a triangle, it could be a circle, it could be a rhombus, it could be whatever you want. It's pretty open to interpretation.
cool.
This could actually be a collab too with robotics because they work with Arduino.
Yeah.
It wouldn't be a bad idea either.
Hey, go get one.
You could work on like the diagonal manufacturing of everything else,
Yeah.
and then we could work on the coding.
Well, like maybe for like a minute, let's just discuss what do we want to do? Just look like that and just be able to flow. That's it, right?
I think we can make it more complex. A little
What
bit
can we
better.
add?
If we can,
Yeah. Well, like this one, you can actually like steer it. It doesn't just like float. You can actually like, you see the propeller in the back.
because like I'm thinking like, what if we put two fans on it so it could go like really fast? That would be sick having two of them. So we'd have to like design it though.
We gotta start with the biggest surface area.
Yeah.
Hello, Dan here from howtomechatronics.com. In this tutorial, we will learn how to build an Arduino-based RC hover to the battery voltage. If the battery voltage drops below 11 volts, we simply light up the indicator LED. And that's it. In case you need more details, you can check out the other suggested tutorials,
We could do like
and so you will be able
that
to
one
fully
game,
understand how
Rocket League or
everything
whatever.
works. I hope you enjoyed
little
this
ball
video
friends.
and learned something
Yeah,
new.
it
Don't
sounds like
forget
fun,
to
no?
subscribe and
Yeah,
for
let's
more
do that.
tutorials and projects, visit howtomechatronics.com.
Yeah.
I mean, I could try making.
Okay, so-
I can try making one
Yeah,
that could.
and they have a bunch of examples. Like here's like another one right
Yeah.
here. Like there's a bunch of like this one's like a lot more simple in terms of design. And once again, that just shows you how versatile a hovercraft really is. It's not
Right.
limited by your design, because like
Is that a mini boxer engine?
what's it?
A mini boxer engine.
Oh yeah,
That's awesome.
yeah. So
Cool.
yeah.
But he's only able to hover in a surface. Can it also hover in the water? Like if we put it in a pool,
Oh, see, well that's
Okay,
that's something we could test.
right? Because we have to find if it's dancing into the flow, right?
Yeah.
It's limit, yeah.
Yeah, because if we're able to make like a small scale one that's able to go over like land and water, then theoretically when we bring it up to full scale, we should be able to have like an amphibious hovercraft is able to hold like a larger weight.
Well, how about let's start with just have it.
Yeah, for the water, we'll try it over like a puddle first.
Yeah, exactly. But like,
And then we'll throw it into
Or a
like
kid-
the
or a kiddie pool.
We'll get a kiddie pool.
I don't know how to swim.
We'll get a kiddie pool.
We'll get a kiddie pool and then just like test it and see, and like
But we can still
if we make
my
another
sons,
better
they're
one,
really
like a
good.
better version of the one that we have that
So
is
it's
able to flow,
Just,
Yeah.
they're
It's
chubby though.
race with it and see
Yeah.
how far we can go.
Yeah.
But you guys agree we should start it off as small as if let's try to make it float,
Yeah.
Yeah.
I'm,
Yeah.
right?
I'm down with it.
Something
That's
small
cool,
that
yeah.
it can float in a kiddie pool. That's what I mean.
Yeah.
Let's do Rocket League.
I guess the ultimate goal is Rocket League.
Oh, yeah, let's do it.
Feel like a ball.
It's a little bit-
Yeah,
that's
it's
gonna
a
be
beach
the
ball.
case of
Hey, I'm
thermite
Jeff.
and water.
Let's try it.
We even done like.
Do we need to what's it called? Like cover the electrical components in it?
Yeah. Because with that, in the previous video, like they have a waterproof box that they have like the engine and electrical components in. So we have to do like the same thing. And I once again, when on the small scale, we're pretty open to do whatever we want since we could 3D print all the parts. But the only thing is when we're designing, if we want to make it full scale, we have to keep in mind like, okay, I was able to 3D print this, but when I do full scale, like how am I going to actually manufacture this? Like
Yeah.
what materials am I going to use? Is it going to be too heavy at that point? Like,
That's something
so on.
else, yeah.
Yeah.
That's
Okay.
something else, yeah.
So what should we do now? Come up with the design of what we want it to look like at least?
Yeah. Yeah.
Um,
And for
Can we do that? Can we do that?
yeah, actually,
With that?
wait, does anyone have markers? Because like we just like there's a whiteboard back there, right?
I gotta go.
Yeah,
Don't
the-
tell me my markers are there.
Yeah, but for now, like instead of like going like oh like let's do like look at SolidWorks, let's just draw out like designs and like figure out okay like what do we like, what do we don't like that
Can
type
we
of stuff.
show like more examples?
Right now.
Oh yeah, this is more examples.
I'll let you guys know my designs.
Over.
Take care, guys.
See ya.
I like that one.
Ooh, was there
Cool.
Bentley?
Let's
That's like
get
the
it like
Bentley
that.
of Pokemon right there. Is that one SolidWorks?
This
left?
guy?
Yeah, it looks like it, right?
Yeah, this guy's SolidWorks.
Alright, straight up.
Wait, click on that.
Two rotors now.
Yeah. Totally do that.
See how simple it is? Like a piece of cardboard and like a trash bag.
That's funny.
Oh, see, and then once again, like, see how they do it? Like, here's a fan. It fills up the curtain right here, and then it goes down, and then it pushes out. So in this version, they don't have the fingers. And like I said, fingers aren't like an absolute necessity. You can have one that doesn't have the fingers and still have it go over water. It just gives you more stability. That's the only thing.
Okay.
So yeah, see. Yeah, so get some brushless DC motors. So you laser cut out the hole.
Yeah.
Yeah, see, this is something that's like very like doable with like the stuff we have.
Yeah, and it doesn't look too easy. It's something like, oh wow, we kind of need to put some time into it.
Yeah, like
Yeah.
especially like the hole here.
Yeah.
The hole defines like everything. So like this is like a conventional kind of like a boat shape, but you could do whatever you want. You could put like if you want, you could put more places where instead of letting the air just go wherever it wants in the hole, you have like some specific channels that actually push into it to give you more greater pressure. So that way you don't need as powerful a motor. And then we can say like, oh, like how are we going to design those channels? Which way are we going to disperse them down? Like that type of stuff. And we get more complicated on that side.
What are they doing in the next one? That one is they're sewing the things up. Oh, how cute.
And then yeah, they laser cut.
Click on nylon, complete the sewing margins. Use or something using a certain sheet. Oh, this is a class project with someone.
Yeah.
We should do something like this.
Yeah, can we do this?
Yeah, we can do this.
Sick.
Yeah, look, oh look, it's
Hovering
floating.
on water.
Can we like replicate this one?
Yeah. Like,
Start
cause
somewhere, right?
yeah, cause like, well, they don't have the SolidWorks, but like, we see all of like their process, and that's all we really need.
Mm-hmm.
Hold up, let me see what?
Let's see, can we put it in writing on these?
Check out the bill of materials.
What does he have? The twin bars?
Mhm.
Oh wow. Oh, he has a list
Holy
already.
crap.
He has a bill of materials.
That's actually not bad.
How much
Check
does
the
it cost?
business.
Damn, we're like,
200
$200?
wow.
Oh, that's a good one.
That's a pretty sizable amount, but still, it looks pretty cool.
Bring it down to $100. What does gems of wisdom have? Do your homework, do your research. See if you like this
I'm
one.
gonna go to Michael's this weekend. Can I see that?
What does that say? Actually design your circuits
I like to
before
go
you
to
build them.
Michael's.
Yeah.
Don't laugh, I'm serious. Yes, actually do design calculations.
Yes, characterize your motors. Also keep the design schematics.
Yeah. See, with that, like, we would need help with like the electrical part of it.
Yeah. Okay.
But in terms of, like all the other design, like this could possibly be like a collaborative thing where, like electrical engineering club like helps us out with like the doing the whole programming stuff. Or even that, like maybe we could take like the Arduino based thing that they have with the previous one, the mechatronics, and put it in here.
That's not a bad idea. We could do that.
Electrical hovercraft. Oh, they have everything. Lift fan. Motor driver circuits.
God, yeah, they really do have everything.
Yeah. So with this, like, since you have all the information, like electrical engineering should be able to like help us out with this part.
Single 7.2 volt.
With this mechanical hold.
First prototype achieving power.
Oh, it was the same thing it was on for. I'll be like
That was like what their like first
prototype one, Mark 1 prototype.
Some cardboard trash bags, staples, and tape. This early prototype featured a simple wall skirt and was intended solely to test the lift capability of the Delta blower.
It can easily lift 20 pounds.
Wow.
That's cool. I like it.
Okay. Two independent controllers? Propellers? Independently controlled propellers.
Oh.
Implement differential testing turning.
Because of that, instead of having rudders, like they basically have a thing where like they turn on one rudder to go right,
Yeah.
and then they turn so it's like track controls. Instead of a rudder, they have a track control system.
Planes do that too. So planes sometimes, like when they need it turn like onto the runway, they turn off one of the engines, and you just start turning with the other one.
Track control. So that could be like an advantage if we don't want to have like a rudder system.
Wouldn't the turn radius be a lot bigger then?
Yeah.
Our marketing protest most of the design features that would be used for final routes such as experimental bag skirt, a laser cutter fiber board box frame that double as